Today, I'm joined by Mr. Madhusudan. He is the CEO and one of the co-founders of Inco Semiconductors. In this episode, we go beyond headlines to understand where India really stands in the semiconductor journey, from design maturity to equipment manufacturing capabilities, and what realistic milestones look like as we move towards 2030, 2035. We also explore how global trade, new FTAs, and even questions around labor productivity and agricultural efficiency shape India's long term competitiveness. This is a grounded, honest look at India's semiconductor future. Let's dive in.
So thank you for doing this. And today's conversation is about getting to know semiconductors. And since you're
Okay.
always involved in dairy farming and related trade activities, I'd like to pick your mind on that as well. So the first
Sure.
one is about Inco Semiconductors itself. Tell me a little bit more about it and also your experience in IIT Madras and over the years.
Okay. Over the years, is a
Mhm.
well, I had joined IIT Madras in 2012, basically to assist in a bunch of research programs. Professor Kamakoti had invited me. So, I guess as a project or research consultant, I keep forgetting the exact position. So, the main project that I was involved with along with Professor Kamakoti was called the Shakti project. Shakti was basically an effort to develop homegrown processors. It actually is a two-pronged effort. One was to create capability, create talent in processor design, also create some open source technology which can be used to seed further research. And Neil Gala and Arjun Menon, the two other co-founders of Incore from IIT, were PhD and master's students at that point of time. And in 2017, the Shakti project had its first tape out. And in 2018, the three of us, along with Gautam Doshi, who was helping us from the Intel side on the IIT project, floated Incore. Incore was not based on the work that we did at Shakti. It was inspired. I mean, we used the same RISC-V standards and so on, but Incore developed its own cores from scratch. And in 2023, Sequoia India, which is now called Peak 15, funded us. And currently, we are shipping products, have customers, making money. So it's been an interesting journey. The company is about 8 years old. I come from a system design background. I started my career with HCL, then went to US to work at Sybase, then was in Singapore for 10 years. So I've been mostly on the system software side is things like operating systems and databases and file systems, right? For the average person would probably in their, I mean, non-computer science person would encounter Windows or Linux or Android, right? So development of those is what is called systems programming. So I come from that background. I come from more of a software background. But I
Okay.
had also run a design services company in Singapore. I ran the Asia Pacific operations called GDA Technologies out of there. And that dealt with both products and design services in ASIC and embedded. So I had actually transitioned from a system software area to developing electronics, hardware, and chip design. So that kind
Okay.
of led to a bunch of other things. And
Okay.
I'd done a bunch of startups after GDA in Singapore. And 2010, I came back to India
Okay.
to start a mobile phone company. It is one of India's first mobile phone design companies that we would be designing and manufacturing our own phones for third party, not under our own brand. Not much of a demand. That company, in some respect, was destined to go bankrupt because it's a little too early for its time. That's all. And in 2012, we closed shop and then I joined IIT.
Okay.
So that has been the journey.
Yeah. Okay.
In Core itself started doing processors very similar to what we had done in Shakti, but we very soon pivoted to, we realized that if you just provide a processor, then people have to take our processor, add other intellectual property components, put it together. So we expanded our portfolio to include not just processors, but other uh, components that go around the processor. And we started providing what is called SoC subsystems. That is a kind of like a processor complex or other things so that people can start with this big block and then build a chip. But soon we realized even that was not sufficient to speed things up for a lot of customers. So we created this tool called SocGen, which takes our components, takes other third-party components, and you give a definition of a complete chip. It builds the chip at a RTL level. There's something called an FPGA. So we can, it generates code that can be run on an FPGA immediately. So essentially you can architect and churn out a chip at an FPGA level in less than 10 minutes, along with documentation collateral. So we are working not only to provide intellectual property based on RISC-V to create system on chips, we are also providing automation tools that put our IP and third-party IP together to get your first cut proto in less than 10 minutes.
Okay, yeah, that sounds good. And but before we dive into that, I want to understand semiconductors industry a little more. I think we have
Mhm.
a common misconception that racing to the most advanced chip has been, one of the biggest factors. But I think in one of your LinkedIn posts, you mentioned that building packaging design and fabricating units is almost as much of a race if you can do that in scale, right? So yeah, expand on that. And
Yeah,
just to one more point to add to that, I think in 2021, 22, there was a chip shortage, and most of these chips were actually the I think
older node
about
chips.
28 older. Yeah,
Yep.
exactly. So the most
Actually, a
advanced one were
lot.
available in volumes, but the older nodes weren't. So, and understanding this scarcity in semiconductors is something I want to do. Yeah, if you can expand on that.
Yeah. See, semiconductors span a pretty large spectrum, correct? So if you look at power semiconductors, which is like part of your battery charger or a motor controller and stuff, the passive components in there are called bulk semiconductors. They are at like 350 nanometer, 500 nanometer and above. There are a lot of chips still being fabricated at 350 nanometers. 180 nanometers is actually quite common. Power devices do at 180. A lot of smart cards still recently were at 90 nanometers, right? So 350 nanometers to 40 nanometers still, I think, is majority of the parts shipped in the world in terms of active chips. They may not be maxed by value because an NVIDIA GPU can sell for $40,000, whereas a single part of a MOSFET might sell for 2 cents, right? So don't let the market price fool you into thinking. Purely in terms of volume, most of the volume is still 14 nanometer and older nodes.
Okay.
And for you to have a semiconductor industry, you need to have a complete ecosystem of people who know how to set up fabs, people who know how to run fabs, the chemicals that go into a fab, purification of water, construction technology. There's a lot of things. Those you can very easily learn in older node, right? So we need a huge ecosystem to sustain a fab ecosystem. And it's better to learn that with an older node rather than jumping onto 7 nanometer or 5 nanometer or 2 nanometer. Besides, who's going to give you a 5 nanometer or 2 nanometer technology? Availability is also an issue. So, given the needs of the country, if you take your typical washing machine or air conditioner, they're all older node parts. You won't even find a 28 nanometer part in there. You'll be lucky if you find a 14 nanometer part. So the vast majority of semiconductors consumed in any country, including India, would be older node ones, and we need to satisfy that. My standard uh, statement in this matter is India should focus on chips costing below $10 first and see if we can capture 20 to 30% of the world market for those chips. Because below $10, the margins on chips tend to be on the lower side, which means a lot of Western companies would like to get away from the market because, given their cost structure, they need to sell high margin chips. Your typical, I'll give you an example. A typical Bluetooth wireless chip from China or from Asia sells for about 65 cents. An equivalent part from a Western or even a Japanese or Korean company would probably be selling for $2 to $3. Granted that the European part would have more features, would be more sophisticated, but if all you're going to do is take a remote control and just turn your AC on and off and its temperature has to come, you don't need a fancy part. That's where the volume is. So India is going into automating electricity meters, right? So you got an electricity meter chip, you also got an RF chip which will take that reading. It, Whenever somebody with a meter reader comes by, it simply has to say so many units and some 10 numbers it has to transmit. How much of sophistication do you need there, right? So if you go and sell a $2, $3 part for that kind of application, it's not going to fly. So the
Hmm.
vast majority of our requirements for us to get to a certain level of automation probably needs only chips in the 180 to 65 nanometer, not even 55 or 40 in lots of cases. So we need to focus on that. And more importantly, when you talk semiconductors, correct? People have this habit of, see, the semiconductor industry is six different segments. You have intellectual property companies, you have fabless semiconductor companies, AMD, NVIDIA are examples. You have design services companies like HCL, Dassault. You have CAD companies which provide the software like Synopsys, Cadence. You got fab companies like TSMC, and you got OSAT, right? And then you got construction companies which supply, which build fabs for you. You have semiconductor equipment manufacturers like ASML. You also have chemicals and other ancillary suppliers, right? So there are like 8 or 9 different segments in the semiconductor industry. My standard advice is always split it into 8 or 9 segments and you chart a path for each segment separately. So, fabulous, the goal might be the 10 most common chips that are used in India should become local by 28, 29, and we should be, say, shipping about 100 million chips by that time. That's a nice goal to have, right? So, even there, if you take a $10 chip, the fabrication cost which goes to any fab is probably dollar, dollar and a half, maybe two, depending on the complexity. 70-80% of the value is still in the intellectual property, in the design, and in the OSAT, all of which is captured in India now for low end chips. If you can capture 80% of the value or even 85% of the value without building a fab, why not do so? That doesn't mean you don't build a fab. I'm simply saying let the fabless industry evolve in its own path. Let the fab guys evolve in their own trajectory. Let the OSAT guys do the same thing. Let the equipment guys do it, right? So we should have separate goals for each segment of the thing, and you should have each needs a dedicated program like a PLI. There's no one size fit all. So one
Got it.
area that is commonly ignored is semiconductor equipment manufacturers. Yeah, you can put a fab, you can do your own chips, but ultimately, if all the equipment comes from abroad, what happens if there's an embargo, right? So we need to do that also. So there's
Okay.
no monolithic semiconductor industry. There are 8 or 9 segments
Ecosystem.
in the industry, each which needs its own direction, its own uh, funding methodology, its own incentives.
Hmm. Okay.
I'm an expert on only one, maybe two of them, right? So I'm not going to tell how you need to nurture an equipment industry or how a fab. I have no clue. Right?
Okay.
I'm an IP guy, and maybe partly I know the fabless industry well. So I will stick to giving gyan on that, and that also should be taken with a sack of salt, because everybody gives advice. Whether the advice is good or not, it's for you to
Yeah.
decide. But the eight
Yeah.
other segments, 6 or 8 other segments that are there in the semiconductor industry, I'm not an expert. People should be talking to those experts and figuring
Okay.
out what to do in those, right? So that is how
Okay.
we should be looking at the semicon industry.
Okay. I think that's clear. But one more thing you touched upon is the export control, right, that the US has.
Yeah.
For US NATO allies, I think it's, there is no limit as such. But for tier
Mhm.
two, which is the category that India is in, there is an upper limit as to how much we can buy. So I think, do you think this is costing us in terms of being able to produce our own compute internally? And also,
Not,
when does this become a threat in the sense, even though we need more capacity, we won't be able to buy it? And yeah.
I don't think it has hit us. I think earlier during Biden's time, we had a limit of 50,000 GPUs that India can procure. We came nowhere near that limit. I'm not
Okay.
worried about embargo and stuff, so I'm not even getting into any political debate.
Hmm.
But during my lifetime in the industry, I have been hit by two sanctions. One in 1988 when the US put an embargo on Cray, and one of our research science shoot was supposed to get a Cray, and they couldn't get it. They were doing some experiments in theoretical science. They're not doing any weapon stuff. But so I was at HCL at that point of time. So we quickly rigged a 16 CPU box with software and all that and kind of helped save the day then. Then I think after the second set of nuclear explosion, there was some embargo and all that we had to do local. I'm not worried about a technology denial regime. I mean, India is not a pariah state, all of that. But purely for strategic autonomy, we have to make sure that we have the freedom. That's all. Because you don't know what the future may bring. In terms of design ability, India has got enough people to design chips as complex as an NVIDIA chip or an Intel Xeon or anything. That's not a problem. There are some specialized chips where we may not get enough people with the appropriate algorithm knowledge because they may not have worked on it. But even that I think has gone away because enough MNCs have R&D units over here. So designing a chip in India is not a problem. Getting access to a fab which can fabricate that is the issue. Currently, we have full access to Taiwan. We are not embargoed.
Okay, okay,
But
that's good.
even if there's no embargo, the problem also is there's a shortage of fab capacity at the highest end, right? So if you go to TSMC, there's a huge queue. If you're
Mm.
from India, I doubt whether you'll even get the time of the day because naturally we are not going to have volumes like Apple or AMD, right? I'm
Correct.
not blaming TSMC. Obviously, they'll give capacity to people who give the highest volume. See, Indian customers typically tend to be very low volume. So if I were the CEO of TSMC, I would also prefer Apple or other companies because they give volumes. And as a CEO of TSMC, he or she is answerable to the shareholders, maximize the profit. So it's not that we have a problem with anything, but given the fact that 2 nanometer and that kind of tech is short in supply, unless you're one of the biggest buyers, you'll be put on a long waiting list. So it's not an embargo, but you will not get access to technology because of other constraints,
Other priorities. Yeah, got
other
it.
priorities, right? So it doesn't mean we jump onto 2 nanometers. We need to start developing our own processes, at least till 28 nanometers, which is what the Tatas are doing. So if you got
Okay.
homegrown tech till 28, 22 nanometers, a vast majority of the designs would be taken care of.
A breakthrough in Indian research is GaN, gallium nitride. Can you
Yeah.
expand the significance of this? And also, would you say sub 22 nanometers is a separate game altogether? Designing, building, packaging, all of it is a different game where it will require geopolitical alignment. But about 22, we should be able to achieve, let's say, most of it in 5 to 8 years. Is that realistic
No,
timeline?
even, no, even earlier, the Tatas will probably be start doing 40 nanometers by
Mm.
28. The 28 nanometers in development along with PSMC. That will probably come by 2030, 32 time frame. I have no idea. I'm just speculating here. It's not some
Mhm.
uh,
Mhm.
gyan that I got from them. I'm just assuming that if they do 40, another 4 years, they'll do 28. You
Mhm.
need to talk to them to get exact timelines. But even 16 and 12 is not a problem. If you look at what happened in the industry, the two uh, smaller fabs, smaller as compared to TSMC, not small fabs, Global Foundry and UMC, stopped at 12 nanometers. So it is relatively easier to get technology till 12 nanometers. Sub 10 nanometers, only three fabs went ahead, right? Samsung, Intel, uh, and TSMC. And now there is a fab called Rapidus, which is using, I think, IBM's technology, if I'm not mistaken, to build 2 nanometer chips in Japan. If they come aboard, they'll be the fourth one, getting into the sub 10 nanometer range. Older nodes, it's a business question as to what makes sense. China is building a lot of older node fabs. Coming to gallium nitride is a compound semiconductor. It's basically used for power and RF. But a lot of people are getting out of gallium nitride like TSMC because the volumes are not large enough for them to justify. See, very large companies also will go after a particular market provided they get good return of investment on their management bandwidth. For a very large company, see, you do a startup, you may find a $5 million business interesting. So would I. But TSMC, if you tell them, boss, the revenue for that product is only 10 million, they'll say, not interested. So normally Intel, for example, I think the yardstick was if they need to acquire a company or work with somebody, Unless you're doing like $1 billion in turnover, then it's not worth the while, because
Doesn't
there
make
is a
sense.
cost to there's a cost to management bandwidth. So it's a scarce resource. So you have to allocate it properly. So it's not wrong. So gallium nitride volumes have not gone up that much, at least not in terms of people's expectations. So TSMC stopped doing gallium nitride. Other people are also kind of backpedaling. But gallium nitride will shift significantly to China, India, and other places. India IISc has research effort in gallium nitride. So we have our own little fab over there. More fabs, I think, are coming up. But more importantly, we are innovating in gallium nitride. There recently was a paper from IISc that I reposted in LinkedIn about a week or 2 weeks ago, where they had made some interesting discoveries in gallium nitride transistors, leakage, and so on. It has partly been driven by our Indian Air Force radar program. That's how DRDO funded that, right? So the Uttam radar that will go into the second batch of the LCA Mark 1A and into LCA Mark 2 and AMCA and all of that is transmit receive modules designed and manufactured in India.
Okay. And moving the conversation to the trade side between India, US, India, EU, all of that that's happening. What do you think about the trade deal in general and also about productivity? I think last time we did speak about this, but
Yeah,
there is some inconsistencies. I think over the week it has been changing. Now pulses have been excluded from
remote.
the.
Yeah,
Yeah. So what is the trade deal going to be? Do you think it's going to be evolving? Both sides trying to
it,
push
it, it,
in.
it, 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 it will evolve. Look, as I keep saying, right, there's no point in blaming people. It's a give and take. India has lesser leverage with the US because we run a huge surplus. There's not much we can buy from them. So, but we need their export market. So we're a little bit of a disadvantage there, right? So that has to be negotiated. And I think we have talked about Apple's also, right? Apple's the US subsidy is not very high. They do a more of a market support. That is, if Apple prices fall, the US Department of Agriculture, I think, buys surplus apples to keep the price up. But compared to the subsidies given for other crops, I don't think Apple is given that much subsidy in the US. I may be wrong, but I think that's what I said. India has got a bunch of problems. We don't have infrastructure, we don't have cold storage, our yields are low, our temperate climate is actually reducing apple yields further. Only Kinnaur, I think, grows okay in Indian climate. So whether we should continue growing apples in those regions with global warming coming, not an easy question to answer. The the bigger problem is not the tariffs. The bigger problem is if you take apples, for example, apples tend to get fruit flies. And US has got its phytosanitary standards than we have. And I think one of the points of discussion was if a product passes US standards, then it should be accepted in India. But that brings about so many questions as to why should India not have its own standards? Or, but if you're going to duplicate a US standard, there's no point having an Indian standard. But if an Indian standard is significantly better in some respect, then we should stick. Correct. So there's no one size fit all answer to this. And the bigger issue in trade is actually not the tariffs. It's almost the tariffs are a red herring. There are issues like evergreening of patents. There is issues like uh, taxation on digital services and so on, right? So the data sovereignty and all that. So there are some very tricky subjects that are coming up as part of the trade negotiations that never used to exist as part of the trade negotiations before. And the government has, I think, clarified that discussions for those will not happen in the preliminary agreement. That is the one of the basis of discussions for the broader treaty agreement. That is still some ways off. So my standard advice is unless you have seen the text of the agreement that formally comes from the government, it's pointless to speculate. You don't have the data, so your opinion is as good as mine.
Yeah, makes sense. And I want to ask about GM-derived products. We are using that indirectly, right? So there is still some sort
Yep.
of resistance. Do you think it's scientific, political, or economic? What do you think are the driving forces that generate so much resistance to GM? Even though we've seen that the yields are close to 2 to 3 times in US and China than India sometimes, and this
Yeah.
has still made us actually look into it and see how we can.
See, GM is a tough subject because there is a lot of politico-economic issues attached to it. Not getting into the politics. fundamentally, the problem is the GM industry has not been very transparent. So there's been a bit of suspicion. Okay, what happens, right? The
Mm-hmm.
best way to settle the GM discussion is to transparently share all data. Then people can take an educated guess. It's the absence of data which is causing concerns, and validly so, because if see, the problems with GM are across multiple dimensions. If it is a special genetically engineered seed, then the whole Monsanto thing was there, right? So the seeds are patented. You can't
Yep. Yep. Yep.
make your own seeds. You have to buy every time. So there's economic issue
Fertilizers
there.
and yep. Yep.
Yeah. So that's there. But we do have, I think, I'm not sure that we got GM cotton in India.
We
I
have
think we have.
Yeah, we
I
do
think,
in cotton, but
hmm.
it is limited to per crop. There is, yeah, arguments going on whether they'll allow that or not. But illegally,
Yeah.
it is being sourced, and it is,
Yeah, yeah, yeah.
yeah. So it is taking shape in one form or another. But just the fact that we don't have enough information to even comment on it, I believe it was.
That is the problem, right? Because there has been a history of hiding data. People are suspicious. The
Yeah.
only way you'll settle the GM discussion is to first be completely transparent with all the data,
Mm-hmm.
and then slowly figure out where public opinion is headed.
Can India improve productivity without consolidating land holdings? This is something we spoke about last time as well. Or do you think fragmentation is the real bottleneck that we'll have to take care of it first before proceeding to increasing productivity?
No, productivity can be increased without farm consolidation. You just need more mechanization. But more importantly, uh, SHOs and collectives are getting formed, uh, self-help groups. We need more of that. So we don't have to club landholding together, but we need to have larger entities. One of the advantages that New Zealand farmers or US farmers or Australian farmers enjoy is scale. So farmers have to figure out how to get to scale. And for trade, I always jokingly point out, right? We should just let the Indian farmers talk to the US farmers, the smaller ones, and figure out, because there is also this fear of each other. Look, I don't have a magic wand which I can wave and say, this, voila, this is a solution. I'm not even claiming that whatever perspective I'm offering is valid, or any suggestion I make, I have no illusions that it will solve the problem. I'm simply saying that unless we have extended, frank discussions about all of this, we won't even have the basis to build a solution. We need to dial back on the rhetoric a little and scientifically look at data, evidence, and then come to a call. Won't take long. We're talking few days, other things, right? But we seem to be unwilling to. All of this is grunt work,
Yeah.
and so you should be willing to do that. Then it'll happen.
Back to semiconductors a little more. Well, how do you think the industries and institutions are doing? I think we spoke about this last time in terms of engineering capabilities. And you also mentioned that VPs of marketing, now they'll have to take it
Yeah,
forward,
yeah.
right? So
I think
yeah,
the
please explain.
fabless industry is coming along well.
Mhm.
The biggest problem companies have is, look, you can do one or two chips well, but if you need to keep adding products, the fabless industry thrives on a broad range of products, right? So we need good product marketing people who are absent. So we have excellent engineering colleges that are churning out good engineers. They need to be more trained, and if you're an electronic student, you need more exposure to semiconductors in undergrad school itself. But all of that can be sorted out. The biggest problem that you have is in figuring out what products will sell in the market, what's the pricing strategy. The challenge is not technical. The challenge
Definitely.
is commercial. Product ideation and commercial. So for that, we need senior marketing folks. Sales folks, we have enough. We need marketing folks. And once you get that, then it'll be easy to deal with other countries, right? So
Mhm.
there is a big lacunae in people who can ideate on products, who can launch a product. It's not nothing special about that sector. It so happens that most of the companies are working on the tech stuff and not on the marketing stuff. So we never churned out marketing people. This is not a problem in other industry. If you take Royal Enfield or TVS, or I can name any bunch of categories, people have successfully advertised, launched products.
Mhm.
How did they do that? I mean, same culture, same city. This
Correct.
is a two-wheeler factory and so a semiconductor factory,
Makes
right?
sense.
So there's no shortage of talent. We just need to identify that. But there is a shortage of people who can ideate, saying that if you, so for example, say if you're doing a motor controller driver, right? Should you aim for ceiling fans or should you aim for heavy appliances? Those kind of questions. So it
Mhm.
needs also needs to be people who are well entrenched in the industry.
We spoke about lithography last time, yeah, from ASML.
Yeah.
Are there companies that are attempting to do this from India to get into component manufacturing, but in a cutting edge sense? Or do you think that's a longer game and we'll have to embed ourselves into the ecosystem first and then think about
But you mean component, you mean equipment, right?
equipment? Sorry, yeah, equipment semiconductor.
They're actually, that is supposed to be part of ISM 2.0, equipment manufacturing. Tamil Nadu
Mm-hmm.
government also has got a semiconductor equipment park, I think next to
Mm-hmm.
Sulur. There are already two
Mm-hmm.
companies churning out products, they're shipping.
Mm-hmm.
So all of this will gradually happen. See, till now, MNCs were coming here only to do
So,
uh, anything software, not just software, hardware also, software design. So now that is changing a bit.
mm-hmm. Okay.
Correct? They are
Yeah.
coming for other parts of the spectrum also. So once that knowledge starts gathering steam, then you will see a change in the kind of company starting here and all that. We need to seed that talent, and that takes a little time, but not unsurmountable.
What do you think is the future of SaaS? And do you think there has been more noise than required regarding the software jobs? What
Yeah,
do
I
you think
think
is?
more noise. I've actually wrote on LinkedIn on that also. It's you still have to mediate technology. You have to put things together, data cleansing and all that, right? So service companies are not going to go away.
Yeah.
May take a little initial hit in volume, but I think they'll recover. You actually need them because they're
Yep.
the people who put the entire system together, and
Mhm.
LLM still can't do that.
Mhm.
But
Yep.
I'm also seeing, I think Tech Mahindra made an announcement a few days ago. They're developing their own sovereign model for smaller models.
Mhm.
So my question is, if people like DeepSeek start publishing open models, I suspect you'll start seeing Indian service companies adopt those models and support it directly to the customer.
Yep.
So very easily
Yeah.
will happen.
Yep. In a medium term to long term, these things will be evened out to some sense.
Yeah. Now, so I don't think there's going to be any massive job losses, but the jobs that get created will probably require more mental effort. No, look, the average engineer is pretty smart here. Just because somebody comes from a tier three engineering college doesn't mean they're not smart or not capable and stuff. It's usually which college you land up is more a factor of the resources you had at your disposal rather than raw IQ. That is why it's all nice talking about merit and scores and all of that. They are very poor indicators on whether somebody will be a good engineer or not.
Mhm. Yeah, makes
So
sense.
in that respect, IIT lucked out because we had a lot of interns and stuff. And then when Incore came on board, we pulled in uh, interns from other colleges also because we were well known in the network, right? That helped a lot.
Regarding the dark factories that we
Mm.
just posted on LinkedIn as well. Here we see that the level of human resource required, right, starts from
Mm.
BTech. So it is
Yeah.
already moving up that value chain. Do you think this can be
Mm.
the future of
It is. It is.
whatever we say as IT software before? Maybe this is the new version of it where we can
No, no,
produce jobs in larger scale.
no, no. Forget IT, right? Look, this is looking far to the future and stuff, but this is just a thought exercise. Okay, so don't read too much into what I'm going to say next.
Okay.
You watch Star Trek,
Yeah.
so so if you look at the job of the engineering team that has to maintain that spaceship, you will get an idea of what humanity's future looks like,
Yeah.
which is
Okay.
extremely complex systems, which
Yep.
involve a lot of base technologies put together.
Mm-hmm.
So the challenge for an engineer in the future will be how to manage complex systems which may have mechanical, electronic, chemical, bioreactors all put together.
Okay.
So we need multidiscipline engineers going
Multidisciplinary
forward,
capabilities. Yeah.
capabilities and all that, right? So it is an exciting future. The challenge is how do you train people? That doesn't mean it makes
Yeah.
easy. But human population is also dropping, right? In places like Japan, Korea, China, even Tamil Nadu,
Yeah,
it's
even
dropping
in
significantly, right? Most southern states have got fertility rates like
below
1.6, 1.4.
below yeah,
Oh, below 1.5 in lots of places. Forget about below 2.1.
yeah.
Tamil Nadu in some places can hit 1.2, 1.3 and all that, right? Extremely low. Now, so a combination of automation, robotics, along with a decreasing population may not be a bad option.
Mm.
Look,
Makes sense.
I'm just speculating and guessing here,
No,
but
I
I
think
think you
yeah,
can
it adds up.
compensate. We can compensate for decreasing population with other things. But what kind of society that will entail? Million
Yeah.
questions. I'm not getting into cultural questions here. I don't know how much of this we addressed. I had helped kickstart a AI task force in 4 5 years ago. Actually, along with Amandeep Gill, who was our ambassador to the nuclear disarmament treaty and related stuff. So he was in Geneva at that time, and then he asked me, "Hey, I'm going to be meeting the commerce minister." I think it was Nirmala Sitharaman at that time, saying that can we suggest something because she wants to do. Then I think somebody else suggested or I suggested an AI task force and that got formed and Professor Kamakoti was the chairperson for that, right? So we have dealt with all of this. Like, but everybody can have an opinion on where AI will end up being. Nobody has a clue. So your guess is as good as mine. But I'm simply pointing out that with aging population, reduced birth rates, more use of uh, computers
Tech.
and robots, tech in general may not be a bad thing if managed properly.
Mm.
That's a big if.
Yeah. 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 On that note, thank you for doing this again,
Yeah,
Mr. Madhusudan.
not a problem. You're welcome.
Hope we'll catch up soon and do
Sure.
an update on what's going on.
Yeah. Okay.
Thank you. Yeah.
Take
Thank
care.
you.
Bye.